there, algebra students. Mr. Laurence here, and I'm here to define a function for you. We've been talking about these functions for a couple days. You've been trying to find them. I want to tell you that a function is a rule. It's like an equation, okay? A rule that assigns each input, the x value, to exactly one output, all right? So let's take a look here. A function. Look at this table I've got here where I could find the nth term and then go find the function that created this table. Look at the input values, right? The x's are the inputs and the y's are the outputs, or the f of x's are the outputs. I really shouldn't call it f of x because I don't know if it's a function, but I kind of cheated and made a function. But you'll see in the future I'll be using y there if I don't know if it's a function or not. So is there any x value in the input that goes to more than one different y value, or f of x value? I don't think so. But let's go ahead and write our function. Let's go find our differences. Looks like plus 2 every time, which means I'm going to have a 2n. And I'm going to do my comparison line, right? Okay, so 2 times negative 2 is negative 4. Negative 2, 0, 2, and 4. And how do I turn these red ones into the green ones? Well, it looks like I'm subtracting 3 every time. So that means for the nth term, I'm going to take 2n and take away 3. That means my function is f of x equals 2x minus 3. Now I'm going to go ahead and graph that. Let's see here. Negative 0, negative 3 is on my graph. 1, negative 1 is on my graph. 2, 1 is on my graph. I think 3, 3 will be on my graph. Right? How many points do I have to show? Well, I only have to show 2. But the more points I show, the more accurate my line will be. Now, the follow-up question, are you listening closely to this, Colton? How many points are on this line? Some of you are thinking 4. You're absolutely incorrect. There are not 4 points on this line. No, there are not. Let me see here. Aren't there an infinite number of points on this line? Doesn't this line go forever in both directions? Right? I just have only shown 4 points. Make it a little thinner, make it a different color. There we go. I've shown the points 0, negative 3, 1, negative 1, 2, 1, and 3, 3. But isn't this a point? Isn't that a point? Isn't that a point? Isn't there a point here? Isn't there a point way up here? If I extend that line, right? That line goes forever. Now, will there ever be a time when any of these x values, any of these inputs, go to more than one y value? I don't think so. I think for each x, there's going to be a unique y in this particular case. That's why this is a function. Okay, that's why this is a function. By the way, there's another way to express functions or test if something's a function. You list your input, or what we call the domain, and you list it, what, negative 2, negative 1, 0, 1, and 2. And then the output is your range. Range, these are important definitions. Negative 7, negative 5, negative 3, negative 1, positive 1. All right, and we map 2 to negative 7. Doesn't 2 go to negative 7, right? Negative 1 is going to 5, negative 5. 0 is going to negative 3. 1 is going to negative 1. And 2 is going to positive 1. Okay, if we had a situation where one of these numbers in the domain, one of the green numbers, was going to more than one number in the range, the red numbers, then it would not be a function. All right, let's look at a couple of examples here. I've got 2 mappings. All right, remember the domain is your input. is your input or your x values, and the range is your output. All right, let's take a look at this one here, this example. It looks like 7 is mapping to 6. That's cool. The input is going to 1 output. Looks like 6 is going to 5. Well, that's cool. But it looks like 5 is going 2 different places, right? 5 can't go to 2 different places and still be a function. We'll call this only a relation. A relation, not a function. There's a rule that will turn these numbers into those numbers, but because 5 is going to 2 different places, it's not a function, okay? It's kind of like a function is going out to eat. Boyana can go to McDonald's, and Jarrett can go to McDonald's. That's functional. It's cool. It's very possible that Boyana would see Jarrett at McDonald's. Very possible. They might have gone together. They might not have gone together. But they might run into each other there. That's functional. But is it possible for Boyana to go to McDonald's and Burger King at the same time? No, it's not. That's not functional. That's only a relation. So you see, this is Boyana, 5. Okay, I'm using that as Boyana. And she's trying to go to McDonald's, the 3, and Burger King, the 4, at the same time. That's not a function. She can't do that. We still might be able to find a rule and do the math and all that, but it's not a function. Okay, let's take a look at this one. Here we've got 5 mapping to 1. We've got 6 mapping to 3. 7's going to 5, and 8's going to 5. Is this a function? Well, let's pretend that 7 is Haley, all right, and she's going to the Olive Garden, okay? And 8 is Nick, and Nick is going to the Olive Garden. I'm not saying they're on a date. I'm just saying they're both going to the Olive Garden at the same time. Not necessarily together, you know, Haley's with her family and Nick's with his. Is that functional? Can they go to the same restaurant at the same time? Yeah, they sure can. This is a function. This is a function. So you see, it's each member of this input is mapping to one member of the output. 7 is not going to 2 different places. All right, so this is a function. Let's see. Let's test this. Now notice I didn't put f of x here because I don't know if these are functions or not. Let's go ahead, and it looks like it's going to be plus 0, plus 0, plus 0. So that means the nth term is going to be like 0n, right? That doesn't say on, that's 0n. So 0n, I do my comparison line, and 0 times 0, 0 times 1, 0 times 2, and 0 times 3, and 0 times 4. And in each case, I'm going to subtract 2. All right? My equation in this case, my function, is going to be y equals -2. Is it a function? Well, let's see. Is 0 going to more than one place? No, 0 only goes to -2. Does 1 go to more than one place? No. Does 2 go to more than one place? No. These are like people. The inputs are like people. The outputs are like restaurants. Can 5 different members of our class go to the same restaurant at the same time? Sure. You do it every day at lunch, right? You go to the cafeteria. You all go to the cafeteria together. This is a function. You could say f of x equals -2. Okay? All right. Now let's test this one. I don't know how to write the equation for this. I kind of do, but it's not going to work that way. It's probably a hint that it's not a function, but let's see. Where's 4 going? 4 is going to 2, and 4 is going to 2 again. That's the same number, isn't it? 1's going to 1, and 0 is going to 0, but 1's going to 1. I don't see them going to different places. I think this is going to be a function. I think it fooled me. Yeah, because 4 is only going to 2. It's listed twice. I'm not sure why. Yeah, on a graph, I couldn't show that twice. Okay. What about if I changed it slightly? Let's change it. Let's use the same thing, except let's make these two negative. Is it a function now? Let's see, 4 is going to -2, but 4 is also going to 2. So if I did my mapping thing with my domain, and I was only considering 4, there's my range. I'm going to need -2 and +2, and 4 has to go to both of them at the same time. That is not a function. Okay, so this is not a function. All right. What I want you to do is I want you to make a set of tables for these two equations. Y equals 5 and x equals 6. They're two separate problems. We'll call this problem 1 and call this problem 2. Make a set of tables and get at least 5 points in your table, you know, an XY table like this, right? Okay, and an XY table over here. And see if you can determine if these are functions. I'll give you a hint. One of them is and one of them is not. One of them is only a relation. But come in with those tables tomorrow. We're going to talk about these. All right, that's it for the video tonight. Feel free to watch it more than once. Mr. Laurence signing off. Have a good night, everybody.